So what about limit as x approaches 0 of sine 1 by x? What can you say about this one? So let me just first tell you how to sketch the graph of this. Okay, so all of you know the behavior of sine, right?
Yes, Professor.
Okay, so what I'm going to do is I'm going to put x here, I'm going to put 1 by x here, and I'm going to put sine 1 by x here. Okay. Okay, so if you recall, sine looks like this. So it's always going to lie between -1 and 1. Okay, so this is 1, this is -1, and its graph looks like this. Right? Okay, so something like that. Okay, so this is 0, this is pi by 2. Okay, and this is pi. Okay, this is 3 pi by 2, and this is 2 pi. Okay, so it's a periodic function. So after every 2 pi interval, it repeats itself. Okay, so basically this is the point 3 pi. Okay, and similarly again when it's going to intersect, completes the cycle, it's going to be 4 pi. Okay, and so on and so forth. Okay, so that's how the graph of sine function looks. Okay, and of course we can continue on the left also. Okay, so it's an odd function, that's how it looks. Okay, so what I'm going to do is this is something that I've plotted in this way, that if I have this particular argument, then I plotted sine of this particular argument. Okay, so what I'm going to do is I'm just going to write these. Okay, so for example, at pi by 2, when 1 by x is pi by 2, then sine is 1. When 1 by x is pi, then sine is 0. Okay, and when 1 by x is 3 pi by 2, then sine is -1. Okay, and when 1 by x is 2 pi, then sine 1 by x is 0. Okay, and so on and so forth. Okay, so so after that, at 4 pi again it will be 0. Okay, and then at 6 pi again it will be 0. So again it's just going to be like that. Okay, now what I'm going to do is I'm going to plot x against sine 1 by x. Okay, so because that's the function that I need. Okay, x against sine 1 by x. I don't want 1 by x against sine 1 by x. Okay, so what I'm going to do is I'm going to convert this 1 by x into x. So if this is 1 by x, then x must be 2 by pi. Okay, if this is 1 by x, then x must be 1 by pi. Okay, this is a 2 by 3 pi. Okay, this is 1 by 2 pi. Okay, and this is 1 by 4 pi, and then we can continue. And notice that what is happening to the value of x here, it's falling, because it was 2 pi earlier, then it became 1 by pi, then it became 2 by 3 pi, then it became 1 by 2 pi, then 1 by 4 pi, then 1 by 6 pi, 1 by 8 pi, and so on and so forth. Okay, so what I'm going to do is okay, I'll just plot these x's. Okay, so let's see. Okay, so this is 2 by pi. Okay. 1 by pi will be smaller than it, in fact half of it, so it will be somewhere here, 1 by pi. Okay, and then 2 by 3 pi is even smaller, so somewhere, so this is 1 by 2 pi. Okay, let me plot that. Okay, and then 1 by 4 pi will be half of this, so this is 1 by 4 pi, and then so on and so forth, 1 by 6 pi, and so on and so forth. Okay, now let's plot the graph of sine 1 by x. Okay, so x against sine 1 by x. So this is x, this is sine 1 by x. Okay, okay, so what do you think is the value of this sine function at 2 by pi? It is 1, so I'm going to put 1 here. Okay, so this is the point on the graph, and then as it goes from pi by 2 to pi, it goes from 1 to 0. Okay, like this. So here we are going from 2 by pi to 1 by pi, and it's going to become 1 to 0. So it's going to look like this. Is that okay? Fine. Now notice that between 1 by pi and 1 by 2 pi, so basically between pi and 2 pi, it completes this half cycle. Okay, so basically I'll also do the same thing. I'll complete the half cycle. Is this fine? Okay, and this is -1. Okay, and then between 1 by 2 pi and 1 by 4 pi, it completes a full cycle. Okay, so I'll also do the same thing. Okay, is that fine? Okay, and then you can continue like this. Okay, so it's just going to become like almost like a vertical graph. Okay, but not exactly vertical, but it's just I mean it's just going to collapse into this interval -1 to 1. Is that fine? Okay, let me just for more clarity, let me just use technology to draw that. Okay, so let's use Desmos. Okay, you can see this is exactly what we have just done. Is that fine?
Yes, Professor.
Okay, now what do you think is the limit as x approaches 0 of this function? Okay, can I say that 1 is the limit? Just let's do this check. Okay, can I say that 1 is the limit? So basically I want to check if 1 is the limit or not. So what I'm going to do is this. I'm going to basically because I know this intuition that the graph is actually collapsing in this entire interval. So it doesn't seem that it is coming close to any single number. Okay, so that says that limit should not exist in this case. So what I'm going to do is I'm just going to do a quick check, if 1, because 1 is also one of the numbers which is getting close to this graph. Okay, so I would like to see if 1 is the limit or not. So what I'm going to do is I'll try to show that it is not the limit. Okay, because my intuition says that because this graph is not getting closer to any single number, so the limit doesn't exist. So I'll try and show that this is true. Okay, so how do you show this? Well, you can consider, so basically I can, what does it says? That there exists an epsilon positive such that this condition holds, right? Such that no matter how small delta you pick, you can always find an x which is between 0 minus delta and 0 plus delta, but fx, okay, the image lies outside this interval 1 minus epsilon 1 plus epsilon. So will I be able to do that? Well, it seems yes, I'll be able to do it, because this entire graph is collapsing on -1 to 1. So if I consider an interval like this, okay, I'll always be able to find, no matter how small delta I pick around 0, I'll always be able to find a point here whose image lies outside this interval. Yes or no?
Yes,
Okay,
Professor.
so this is basically kind of a graphical way of thinking about it, but let me give you the precise argument. Okay, so do you agree that if I consider minus delta to delta, okay, and I know that this 1 by n pi, okay, what is the value of so if x is 1 by n pi, can you tell me what is sine x, sorry, sine 1 by x? What is it? It's 0. Okay, now do you agree that for n large enough, do you agree that for n large enough, 1 by n pi lies in this interval minus delta to delta, no matter how small delta it is? Because 1 by n pi is actually, a number which is getting close to 0, right? I can make this n very big and this number will become very small. Do you agree? Yes or no?
Yes.
Basically, that's a precise argument that, for any delta positive, I can choose 1 by n pi in this interval, okay, such that the image of sine at the image of this function sine 1 by x at this value of x is 0, which lies outside this interval 1 minus epsilon 1 plus epsilon. Is that fine? And therefore 1 is not the limit. Similarly, you can show that 0 is not the limit, and you can actually do that for any number between -1 and 1. So no number between -1 and 1 is a limit, and therefore there is no limit. Okay, you can also show that any number out, above 1 is not the limit, any number below -1 is not the limit. That's kind of immediate, but you can just by using this kind of argument, you'll be able to show that no number is a limit. Have you all understood this? And therefore we are going to say that this limit does not exist. Limit does not exist. Okay,